So on the top of page 574, you can write the following instructions for the general solution. So if a question asks you to find the general solution, or they tell you the domain is everything, or technically they forget to tell you the domain whatsoever, you have to assume they're looking for every answer that's possible. If this is the case, we have two simple steps which connect two things from chapter 6. We solve like normal, from 0 to 2 pi, just like we would solve in chapter 6. Then for each answer that we find, we write all the coterminal angles with that answer, which also comes from chapter 6. And what does that mean? You just have to add 2k pi, where k is an integer, assuming it's in radians. If it was in degrees, you'd add 360 degrees times k, where k is an integer. And that writes down all the coterminal angles. So the actual question 1, you can put a little x through, and we're going to do this question 1 instead. Solve for theta, and this part right here is telling us that they want the general solution. They want every answer that's possible. So you can write this right under question number 1, because we're going to do this instead of question number 1. So general solution, it had 2 steps. Step 1 said solve like normal. Solving like normal means get sine theta by itself. Then do sine inverse of positive 1/7 to get your reference angle. Maybe just a little reminder, that's what you would type into your calculator. Sine inverse of positive 1/7. And as a result, you take that reference angle, you'd write the answer in quadrants 3 and quadrants 4. Remember, in quadrant 3, this would be pi plus your reference angle. In quadrant 4, this one would be 2 pi minus your reference angle. And then once you have your 2 answers, the final step is to write both of them. We put this like fancy squiggle bracket and plus 2k pi. Again, here, final exam, they take off a half mark because I didn't go to 3 decimal places. Oh man. I like, some of you like smirk. You like thinking of me losing half marks. A little bit of revenge, right? Everybody good? I'd like you to try this one on your own. I'm just going to put up the answer. So try it on your own. I'll put up the answer in a bit. All right, how did you do? You can get 1.77 and 4.51? Very important that you do cos inverse of positive 1/5.
That's what I just said. Why did I get the wrong? I don't know.
Right, because you would get cos theta equals negative 1/5, but for your reference angle, you have to do cos inverse of positive 1/5.
We did positive
If you do cos inverse of negative 1/5, you actually get the 1.77, which makes you think you're on the right track. But then this answer is completely wrong. So this is why it's very important that we do the inverse of the positive value. All right, one more to do. We're going to do this one together. Solve for theta. If they don't say anything, it's the general solution. So what I would probably think that would happen first, you might be like, oh, maybe I can factor this. And if you try, this would have to be tan theta and tan theta. The only way to get 7 is 1 and 7. Does my outside and inside ever make 3? Oh, so what does it mean if you can't factor? We have to use the quadratic formula. Quadratic formula would be tan of theta equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplifying this, you would get tan of theta equals negative 3 plus or minus 28 plus 9, 37 over 2. The plus or minus really means there's two answers. There's one answer where it's plus, and there's one answer where it's negative. And we have to find the reference angles for both of these. First of all, if you're unsure if they're positive or negative, actually plug them in. So I'm going to write negative 3 plus the square root of 37 all over 2. And I find that's 1.541. The 3 dots to say I'm not going to simplify that anymore. If I do this one into my calculator with the subtraction sign in between, I get negative 4.541. So I need to find my reference angles for both of these. You have a newer version of your calculator. When I go tan inverse, I can just go and take an answer like that by selecting and push enter. It'll keep all of the decimal places. So I get a reference angle of 0.995. I write 3 decimal places, but sometimes I show these little dots just to remind myself I'm not actually going to round my answers until the very end. Rounding early, if it causes your final answer to go off by a decimal place, you will lose a rounding error E6. If that's my reference angle and tan is positive, it would be in quadrant 1, 0.995. And in quadrant 3, how would I find it in quadrant 3? I would go pi plus my reference angle, all those decimal places, 4.137. Over here, I also have to find my reference angle. If I go second tan inverse, okay, and I want to find the reference angle of this one, I push enter, it's negative right now. So I have two options. I can either use this button and go all the way over to that negative and delete it, or I can just go multiply by another negative 1. Would you agree that would make it positive? And that saves me a little bit of time of until I get to there to delete it. So now my reference angle is 1.354. And it's going to be in quadrants 2 and quadrants 4. Sometimes I don't like to always highlight it. I like to use my store button. So right above the on button, you can store an answer as X. And that way, when I want to find quadrant 2, instead of going pi minus and clicking that answer, I can just go pi minus X. And it finds it 1.788. And in quadrant 4, I could go 2 pi and minus X. Still remembers it 4.929. Those are our answers between 0 and 2 pi. When solving a general solution, here's our steps. Solve like normal. So what we did up till now is solving like normal, chapter 6 question. Now that we've got our answers, we have to write everything coterminal with all of those. So that is just a matter of going theta equals, listing all 4 of them, 0.995. I'll put them in order. They don't have to be in order. And to each of them write plus 2 k pi.
Hi, excuse me, your presenters have arrived.
Okay, excellent, thank you.
You're welcome.
Where k is an element of the integers. So this is big idea number 1 of chapter 7, and it just combines 2 things from chapter 6. Since you've been solving in chapter 6 and you have to solve for your test, it's just good practice to do that. Questions you can circle are 5, 6, and 9.